numerical methods, actually, kay, ginagamit siya because there are mga problems that cannot be solved, again, analytically. So that is, paggamit tao kanang certain process known as the numerical methods. But numerical methods are actually being used via computer. Like, di ba, in programming, kay we need an algorithm. But there are also errors with numerical methods kay ang atuang solutions given here or the results are actually approximation. So with that, we have two types of error. Natay ginatawag na truncation error and the other one is the round off error. Truncation means we chop off kanang digit sa atuang number. Like for example, given this value, tang din na to kani. We have 345.617. Kung i-truncate na to ni, regardless of the value here, kay dili na gid nato na siya i-include. So putlo nato ba? So di na ni appeal. So ang mabilin kay kanina lang. So the other type is kaning ginatawag na round of error. Round of error. And this type of error is, di ba, murag mo ni ang nakasanayan nato because we used to round off digits. Like for example, given the same number, if this is to be rounded 3 decimal places, ang result is ang kaning 7 kay ma-increasean of 1 because the following number is more than 5. So therefore, it will become 345.618. Now, para consistent ta, ang atong gamiton din is always the round off. Pero we have to round our answer into 6 decimal places. Because of the two, between truncation and the round off, si truncation ang mas dako ang error i-compare ni round off. So aside from that, hinapod ta diri ay degree of accuracy or kaning ginatawag na error na ginagamit. So for ato ang topic just now, kay we will be using the term absolute error, and the relative error, in which absolute error is the absolute value of x raised to k plus 1 minus xk, where ang kaning xk plus 1, this is the more accurate value, tapos ang ato ang xk is the lesser accurate value. Tapos, in other kanang process, ang definition for the xk plus 1 is the current value and xk is the previous value. Where again, the current value in iteration is more accurate if compared to the previous value. But for now, because our next topic is the Taylor series, ang kanang x raised to k plus 1, kay ihulog nato na siya as kaning actual na value or kanang tama nga value or true value, tapos ang kanang x raised to k is kanang calculations nato na value. So with that, let's start here with a Taylor series. So what is Taylor series? So actually Taylor series is a part of our power series. So in here, Kai, we will start our definition of the Taylor series by representing it into a power series. So again, with power series mo niyang atuang general solution or general equation, in which we have here a sigma notation starting from 0 towards infinity of our Cn, tapos we have x minus a raised to n. Tapos, ang kaning, saan man ito na, may nagpuan. Time sa ha, kay na ay nag-comment. Dili ko mag-recording kay Google Meet man eh. Walay recording sa Google Meet po. So, maminaw lang jud taan eh. Anyways, this topic also is nasa to ang SIM. But I do have a recording pero kanang noisy. So, I prefer to change that one. Kanang actual na lang na discussion. Sige na ha, kay murag lisod magka ng tanggal-tanggal og screen kay entire screen akong gigamit dili window kay si window lag. Sige, balik ta. Tapos, unsay nindot na color? Sige, red na lang para maklaro. Okay. So, kato, sige ito kong giingon. So, this is the power series. Now, if this is natay minus A dinhi, ang A dinhi is actually the center of our series. If our A here is missing, so meaning the center of the series is nasa origin or at 0. But then again, this is Taylor series, and si Taylor series usually kay nagid na siya value for A. So, kumbaga, if this is the function at n is equal to 0, kani na value, so kaning subscript din sa C kay mahimong 0. Tapos the exponent here will also become 0. So any number being raised to 0 is 1. So that's why we have this result. Then at n is equal ni 1, so naatay si 1 din he. Tapos the exponent also becomes 1, so that's why kani ang na-form. And then at n is equal to 2, so mahimo lang po ni siyang 2. Tapos ang exponent kay mahimong 2, that's why we have this value, and so on and so forth. But gikan daw din sa ato ang power series kay maka-form ta og formula for the Taylor series, such as kani. So atong subayon on how to derive our formula. Ay, kadali lang kay natarog na ko ako ang pen. Ay, naku. Uy. Okay. Ayaw sa among chat kay mo sige kog altab-altab wala. Pwede may mga yung PPT. O sige, ibutang na nako ang PPT later.
Thank you, ma'am.
Okay. Sige, balik ta din ha. Mag-derive sa ta diri og formula kung paunsa nakuha ang Taylor series expansion. Okay, so starting with at diri na lang. At n is equal to 0. So recall that generally the function of power series, we have here n is equal to 0 to infinity of our C. But C here is kuan ha, kanang constant. Kamoy bahala kung unsay variable inyo gustong gamiton. Tapos we have here n, tapos we have x minus a raised to n. But then again, it's the same with kung katong atong i-distribute, we have here CO, tapos x minus a, raised to 0. So that's why we have 1. So mamalihog kog turn off sa inyong mic kay naga noise. Tapos we have plus, kambyuhan na pud nig 1, so we have C1 x minus a raised to 1 plus at n is equal to 2, this will become C2 tapos x minus a raised to 2. Tapos nanay pattern. So sa gunso na nga paing ana. Tapos pag si C4, we have x minus a raised to 4 and so on and so forth. Hantod na sa kinalasan, we have Cn tapos x minus a raised to n. Take note that that is infinity. So, kibali, atong buhaton is mag-set tano. So, at n is equal to, at x di ay. Sorry. Yes. Ay, kadali lang kay class na. Alam ko, i-disturbo. Ang bus daw. Basta ang bus, ihatag ugma. Ah. Sige, sir. Salamat, sir. So, sensya sa istorbo. Kaya na akong head. So, again, balik ta. Nawala, na-discard na ako. We have, again, f of x for the power series. We have here 0 to infinity of Cn x minus a raised to n. Where, again, if this is to be expanded, we have Co plus C1 x minus a plus C2 x minus a squared plus C3 x minus a to the 3 plus C4 x minus a raised to the 4 plus that hantod maabot ta sa Cn x minus a raised to n. Now at x is equal to a using this kaning equation. So unsay mahitabo? So at x is equal to a, so we will replace, alaon niya na mo chat guys, kay misod ka ay sige, altab. Ay, wala ko nakamute o, nagalihok man. Sige ha, magkuan na sad ko, magbalik na pud ko ato.
I-open ang mic, ma'am, may question.
Ay, open mo lang. Ay, Apo. Question na lang diretso ha, ayaw na og kanang chat kay. Oh, magsikog ing ani. Mawala na pud to kung gisulat. Ag na lang ko magsulat ato. Pero di na to masabtan gud kung wala to. Basta dat hantod maabot ta sa last na value. Ana. Now, at x is equal to a. Tapos gamiton nato ning kaning equation. So ang tendency, we have f of a. So we have here CO. Pero take note if we will substitute our x with a. So kani ang iyahang result. So natay a minus a. Antod, pag-abot ni C2, we also have here a minus a squared and so on and so forth na siya. So kibali, at x is equal to a, f of a is simply equal ni 0 kay mawala naman ni sila. So therefore, our CO is simply our function at a. So next, atong i-derive ang ato ang function. So deriving our function, of course, this is 0. Pag-abot din we have C1 tapos derivative of x minus a. So we have 1. Tapos pag-abot sa second term here, ay third na di ay. So we have 2C2. Tapos we have here um, x minus a. Tapos raised to 1. Plus we have here 3C3. Tapos we have x minus a squared. Tapos derivative ani is we have 1 and that. However, kung substitutean na po nato na siya og value na a, ang result kay kani sila mahimong a minus a. Kani also is a minus a. So mga cancel na po na sila diri. So therefore, our C1 is equal ni f prime x. So our C1 is equal ni F ay A day ni A. Kay pulihan naman na itong value ni A. So we have F of A. Tapos at F3 ay F double prime at A. So asa na ganitong kaganina? We are until 3A. So kung ato na po din siyang i-derive, naatay 2C2. So naatay kay ang C1 kay ma-0 naman po. So naatay 2C2 tapos we have 3C3 tapos na squared. So we have 3 times 2 C3 pero we have x minus a. Tapos ang sumpay ana kay katunang naatay 4 times 3 C4 tapos we have x minus a squared. But then again, kay ang ato amang x, o sige pulihan, at x is equal to a, so we have f double prime a, tapos naatay 2C2, kani siya, kung i-replace na to si a sa tanang mga x's, so sa sagunson na sila. So kibali, ma-0 na sila. So kibali, ang ato ang C2 is equal ni f double prime a all over 2. Pagkahuman, a third order derivative, we have kanisiya, kung i-derive nato, ma-0 na pod. So proceed ta din he. So with that, we have 3 times 2, C3, tapos derivative ani. So we have 1, tapos we have plus 4 times 3 times 2, C4, tapos this is napay isahang nahabilin. Kay squared man na siya. Tapos derivative is 1. And so on and so forth. However, i-substitute na po nato that x is equal to a. Our triple prime at a is equal ni 3 times 2 C3. So, kay bali, our C3 is equal ni f triple prime a all over 3 times 2. So, similarly, pag abot ni fourth order derivative, wala na sad ni. So, din hinata mag-proceed. We have 4 times 3 times 2, C4, derivative ani kay we have 1. Tapos, ang sumpay ana is based on the pattern ha. So, nana siya 5 times 4 times 3 times 2, C3, and then we have x minus a and so on and so forth. But then again, we will substitute all our x's with a. So, ang result, we have to the fourth order, and then we only have 4 times 3 times 2 na C4. So, kibali, our C4 is equal ni kaupat gi-derive of A all over 4 times 3 times 2. But when we say 3 times 2, when we say 4 times 3, actually that is the same with, ang kanang 3 times 2 is the same with 3 factorials. Ang kanang 4 times 3 times 2, that is the same with 4 factorials. Actually, that 2 here, ang kanang 2 is simply equal ni 2 factorial. So, based again on the pattern, so the next ani, pagkapos sa ito ang fifth order derivative, we can have 5 times 4 times 3 times 2, and that is equal ni 5 factorials. Now, balik ta with the general general na equation. So if we will replace all our C's here with katong mga na-formulate nato or na-derive nato on the next slide, ang iatual day ay Taylor series. So this is Taylor series already. Ang atong Taylor series is equal ni f of a plus kani, sige, itong C1. Our C1 is f prime. So we have f prime of a tapos x minus a. Kaya di ba, ang ato ang gipang derive are all the values of the c. So kani si CO, kani si C1, this is our C2. So ato na siyang i-replace dadto. So we have C2, ilagay ito, F double prime A all over 2 or 2 factorials, and then we have x minus a squared. Tapos pag-abot ni C3, kaniman si C3, so that is F triple prime A all over 3 factorial. So we have F triple prime A all over 3 factorials, tapos x minus A3, tapos, so, utang na lang po na to C4. At C4, do wala din he. Pero si C4 is to the fourth order all over 4 factorials times x minus a raised to 4 and so on and so forth. So this is kinalasan pag-abot din he. So that is based again on the pattern kay ingana naman pag-abot sa mga series. Pagtanaw na lang nato ang pattern na pwede natong ma-form. So this is, di ba, pag 1, so natay first order. Pag 2, naputay second order. Pag 3, naputay third order. Pag 4, we have fourth order. So sa ato pa, pinaka-last na value ana, that is to the order of n all over. Tapos take note na kung unsa ang order dinhi mo pod ang ato ang factorial dinhi as the denominator. So that's why we have 2 factorials, then here we have 3 factorials, and here we have 4 factorials. So generally, this is n factorials times x minus a raised to n. This is again the Taylor series expansion. So this is how to formulate or to obtain the general Taylor series expansion. And with that, we will apply this in a numerical methods. So that is si Taylor series manggod kay kani iyang formula. So it is coined from the one who invented or discovered this one, and that is si Brooke Taylor. Pero ang purpose gid ni Taylor series is kung tagaan kuno ta og point, tapos i-substitute na to na sa function, tapos gihatag pud sa atua ang derivative of that function given that point, kay naa na tay chance na makahibalo kung unsay value sa function give kung sa tanang value sa kanang x. Like for example, at x is equal to 3, mo ni ang value sa ato ang function. At x is equal to 3, ang derivative of that function is equal to ingani.
Excuse me, ma'am.
Yes po.
Ay, ma'am, pwede ta maka-request, ma'am. Pwede white imong gamiton pagsulat, ma'am. Medyo makalibot mo lang red, ma'am.
Basta di po kayo maklaro.
Same, ma'am.
Wala
Di
man
kayo
white.
maklaro,
Ay,
ma'am.
kani. O, sige. O, kani white na.
Thank you, ma'am.
Asa na to kung gingon? Again, we're given a function. Tapos, itagaan po ta og value of this function at a certain point. Tapos, gihatag po sa atua ang value of the first derivative of that function given the same point. Karon, using the Taylor series, kay we may be able to identify or to know the value of that function bisan pag sa tanang value of the x, like x is equal to 1, to 2, to 4, and so on and so forth. So, maoy trabaho aning ato ang Taylor series. Now, using Taylor series expansion in a numerical solution, kay kani ang iyahang formula. So, kana na no, tating taasa. But, katong kaganiha, kaning x minus a, maora pod niha. Kani. Tibali, din sa given ng formula, this is the given point. Kani siya. Tapos kaning I plus 1, mo ni ang kailangan nato i-identify. Now, the formula daw kay kuno. Pero take note that we have here Rn or the remainder. Kay, di ba gani, that the Taylor series expansion is really equal to this one, f of x. Tapos wala na siya hangganan. But sa karon kay naman ni hangganan. So that's why naatay Rn. Now, ato si Rn is actually equal na siya ni fx minus the fxi plus 1. So take note that in general, we have here fx. Mo ni siya ang complete. Kaning xi plus 1, mo ni siya ang kailangan nato i-identify. Lahi pa pud ang fxi. So this is the origin, mo ni ato ang i-identify, pero mo ni siya si complete. Now for the remainder, that is just the difference of the complete minus katong gihatag lang sa ato ang point. So para masabtan na siya, okay, we have here an example. Actually, it's not as complicated na murag ani ang noun. Now, kaning xi plus 1 minus xi, that is the same with h para ma-lessen nato ato ang equation so that our equation will look like this one. So with that, we have here an example. So use 0 through fourth order Taylor series expansions to approximate the following. The function given. So this is our function. Tapos, ang gihatag sa ito ang point is simply equal to 0. And h is equal to 1. But then again, di ba, as gingon ka ganina, xi plus 1 minus xi, that is equal sa ito ang h. If xi nato is 0, so pasabot, ang ato ang xi plus 1 is equal ni 1. Because given man siya. So with that, let's solve this. But before that, kay ato sang substitute ang value of that function using h, which is equal to 1. But take note, since we substitute lang man the value of 1, mo ni siya ang katong actual. So in actual, we have 0.1 or the more accurate based on the katong symbol for the accuracy or for the error. Our x raised to k plus 1 or f1 is equal ni negative 0.1, 1 raised to 4, minus 0.15, 1 raised to 3, minus 0.5, 1 squared, minus 0.25 times 1 plus 1.2. So we have here, 1 niya kaning actual. So 0.1, 1 manatanan. So ako na lang diretsohon ha. 0.1 minus 0.15 plus 0.5 minus 0.25 plus 1.2. So we have here an answer of 0.2. So again, recall that with error, ang ato ang ginagamit is the absolute error. It has a symbol of e raised to k. Tapos we have here k plus 1 minus our x raised to k, where we found out that x raised to k plus 1 is 0.2. So ang atuan na lang din is the value of x raised to k. Okay, so we will start with 0 to 4th order man. So we will start with 0. So at n is equal to 0, wala ako nakakopya. Dapat ako ditong gisulat sa next. We
Excuse me,
have,
ma'am.
yes po.
0.4 ata ng kuan, ma'am. Kanang F1 with a function of 1. 0.4 ata ang answer, ma'am.
0.4, ano man?
Yes, ma'am.
Negative 0.1 minus
Ay!
0.15 minus
Positive ang
0.5
isa.
minus 0.25 plus 1.2 o
Tama din, ma'am.
0.2.
Tama din, ma'am. Tama din, ma'am.
Sige, so kanina lang atong problema ha. So ang ato ang tirada din hikay, pangitaon nato ang error sa tanang order. Magsugod ta sa 0 padulong sa 4. Pero di na ko memorize ako sang suwat ha. Again, our function kay negative 0.1 x to the 4 minus 0.15 x raised to 3 minus 0.5 x squared. Tinaot nga wa ko'y nasayop. Tapos 0.25x. And lastly, we have plus 1.2. So starting at 0 order, sa atong buhaton kay gamiton lang nato actually katong ato ang Taylor series na formula. So again, recall that we have xi plus 1 and that is equal ni f of xi plus f prime xi. Tapos we have here h plus f double prime xi all over 2 factorial. Tapos we have h squared plus triple prime of our xi all over 3 factorial h to the cube plus to the fourth order of our xi all over 4 factorials times h raised to 4. So, dinhi lang ta kutob kay kutob lang man fourth order. So, kibali at n is equal to 0. So, dinhi lang po ta kutob sa first order. So, dili na ni sila apil tanan-tanan. So, with that, at n is equal to 0, our xi plus 1 is equal ni f of xi. So, pila man to? This is f of I plus this is 1. So, that equal lang po na siya sa xi. So, we have f of xi. Pila to xi? 0, no? So, we have here 0. So, ang kaning 0 na ni, mo i-substitute na to sa tanang x din. So, therefore, using Taylor series expansion, the value of 1 and also 0 order, we have negative 0.1, 0 to the 4, minus 0.15, 0 to the 3, minus 0.5, 0 to the squared, minus 0.25 times 0 plus 1.2. So, of course, kay 0, 0, 0, 0 man na sila, ang value ko no sa function at 1 is 1.2. So, with this, kay kailangan nato kuhaon ang error. Now, using the formula again, di ba, we have k plus 1 minus xk, where ang result nato din mo, ano yung makonsider nato na xk. So, we have here, pila to ganina, 0.2 minus 1.2. If this is naka-percent, so ito lang times 100. So, we have 0.2 minus 1.2, so naatay 1. An error of 1. Or in percentage, this is 100%. So, arang kadako sa ato ang error. However, wala pa tanahuman kay 0 to kuan baya nino, 0 to fourth order. So, wala na. Mag-add na lang ko ha. I-keep na lang na ako para sa inyong PowerPoint na yung mga sulat-sulat. So, I'll add for first, for second, and for third, and for fourth. Tapos, pwede. Tapos, next na punta at n is equal ni 1. So, at n is equal ni 1, ang atuang equation is up to x plus 1, we have f of a plus f prime a, and then we have here our h. So, dinhi lang po to for the first order. However, we need to identify the first order derivative. Na, nakalimot na po ko, class. Sa isulat ha, negative 0.1, 0.15, 0.5, minus 0.25, and then we have 1.2. So, we have F1 is equal ni, this is F at 0 plus F prime at 0 times our H. For again, our H according to the problem is equal to 1. Now, if wala gihatag sa problem, literally that our H is equal to 1, so pwede ra pod nga find lang the difference between kung unsa to'y gipangita and the given point because they are the same. So again, in the problem, this is 1. F of O in the problem kaganina, that is equal ni 1.2. So again, si 1.2 kay gikan denhi. So take note that F of O is 1.2. So gamito na lang nato na ang iyahang value ana. But we don't have the derivative. So with that, pagtaon sa nato ang first order derivative of that function. So again, the function is equal ni, sulat na sadta, muni kahasol pag gamay ang screen. So negative 0.1 x to the 4 minus 0.15 x to the 3. Tapos we have minus 0.5 x squared minus 0.25 x plus 1.2. So finding its first order derivative of the original function. So naatay negative 4 times 0.1 x to the 3. Tapos we have minus 3 times 0.15 x squared minus 2 times 0.5 x. Tapos we have 0.25 and this is equal ni 0. Now, at 0, so at 0, so 0, 0, 0 man ni, di ba? Kay, di na ito isulat. Basta, pag substitute nato ni og 0, automatic, ma-0 ni, ma-0 ni, ma-0 ni. So, makabili na lang is negative 0.25. And this value mo, i-replace na to ani. So, we have minus 0.25 times h of 1. So, therefore, we have at 1, we have 1.2 minus 0.25, 1.2. 1.2 minus 0.25, so natay answer din hinga 0.95. So mao kuno ni ang value sa ato ang function at AM1 using the first order. After this, kay apply the error if the error is kailangan i-determine. So the error now is again, we have x raised to k plus 1 minus our x raised to k. Ang kaning x raised to k plus 1, kay dili ni siya mausab. It's always katong 0.2 nga value. But this x raised to k will depend on kung kapila ang order. So in this case, at first order, so we have here 0.95. So we have here an error of anong nag-0.25? 0.2 ra di ay na. So this is 0.2. So we have here 0.2 minus 0.95 in absolute value. So naatay 0.75 din. Pero at least, di ba, nag-lessen ang iyahang error i-compare ka ganina na first, na order 0. So after this, another na sad at order 2, where n stands for the order. So ato ang formula kay madugangan na pud ni og second order derivative all over 2 factorials times h squared. So the formula now is the value of the function at 1 is equal to the value of function at 0 plus the first order derivative times the h plus the second order derivative at 0 all over 2 factorials times our h squared. But actually, ang kaning first two terms pinhi, di ba, ka equal lang man na siya exactly ani. So, pwede na isulat na lang natin iyahang value nga 0.95. Parang atuan na lang isolve is this part. However, kani siya nga part is the second order derivative of the original na function. So, the second order derivative, so kibali din hinalang ta mag-base. So, we have pila man ni negative 4 times 3 times 0.1 x squared minus na atay 3 times 2 times 0.15 times x, and then we have here minus 2 times 0.5 times 1. Tapos kani siya is 0. Same concept that if we will replace our x with 0, so ma-0 na ni automatic ang first term, ma-0 na po automatic ang second term. So ang mahabilin is kani na lang. But take note na natay negative din hina, iwit lang. So that is equal ni 2 times 0.5. So nata din hi equal ni 1. Negative 1. So, kibali, at kani siya nga term, kay pulihan na tuog minus 1 all over 2 factorials times 1 squared. So, therefore, the value of that function at 1 using second order is we have 0.95 minus 1 all over 2 factorials or same nga po sa 1 half times 1 squared. So, nata din hi ay 0.45. Pagkahuman, pangitaon na po nato si error. With error, we have x raised to k plus 1 minus x raised to k equal ni 0.2 minus 0.45. So, we have 0.2 minus 0.45. So, naan na lang tayo 0.25 na error. So again, as observed, our error kay decreases. So gikan sa 1, himong 0.75 na himong 0.25. But then again, we're not finished yet. Kaya naana po ta sa next na order. So that is at n is equal to 3. So pasabot, pag abot ni n is equal to 3, ang atuan ng formula becomes, so at 1, we have here f at 0 plus f prime 0 times h. Okay raha, nabutangan po nag 1 factorial din ha, tapos 1. Kaya para lang mo ng iyahang meaning. Plus second order derivative at 0 all over 2 factorials, tapos we have here h squared. Pero karon dugangan na po nato siya of third order. So we have third order of 0 all over 3 factorials times h cubed. Kaganiha, ang kani siya nga term kay ila to, that is equal ni 0.45. So we have here 0.45. Parang problema na lang nato is this part. But then again, we still have to identify the third order derivative of the given function. So the given function again is up to third order pero x kay kung hinaman taganiha up to second order. So i-derive na pod nato ni siya. So naatay negative 4, huy ka, kataas nakalimot na ko ani, di na ni kahit sa kong powers guys. So we have negative 4 times 3, so madugang si 2, tapos we have 0.1 of x na lang. So minus 3 times 2 times 0.15, tapos derivative is we have 1 because after that, di kanina mang constant. So, ma-zero na ning constant once i-derive na sad. So, therefore, at 0, the third order derivative, kay napa man ni x, kaniha sumpay ni diri matapad pa na din he. So, 0 na ning first term. So, ang mahabilin na lang is this one. So, we have 3 times 2 times 0.15. So, in my calculator, it says negative 0.9. So, kaning negative 0.9 mo i-replace na to aning nga term. So, we have minus 0.9 all over 2 factor, all over 3di, third di, all over 3 factorial. So 3 factorials, kay 3 times 2 times 1 times h, so that is 1 cube. So therefore, a third order derivative di, the value of the function is 0.45 minus 0.9 all over 3 factorials times 1 raised to 3. So that is equal ni 0.3. So next, finding the error. So our error is x raised to k plus 1 minus x raised to k. So again, ang kaning x raised to k plus 1, dili na siya mausab. That is 0.2. Tapos ang xk nato na new kay this one. So we have minus 0.3. So we have here 0.2 minus 0.3. So we have here an answer of 0.1. So again, as observed, the error is diminishing. And lastly, at order is equal to 4. So magtaas na po, madugangan na po ang atuang equation into, so natin first order all over 1 factorial, tapos h raised to 1 plus second order derivative, tapos this is h squared all over 2 factorial plus triple prime, this is h raised to 3 all over 3 factorial plus we will add to the fourth order 0, tapos we have here h raised to 4 all over 4 factorials. But then again, gikan dinhi, padulong dinhi nga term is equivalent to kani. Eh, di ba? Tibuok man na sila. So, therefore, we have here 0.3. Ang atuang problema na lang is the fourth order derivative. So, from here, if this is to be derived again, ang mahabilin is only the first term. So, the fourth order derivative at 0 is kanina lang. Because this is already constant, kung ito pa nang i-derive, ma-0 na. So, naan na lang tayo. Negative 4 times 3 times 2 times 0.1 and then the derivative of x is 1. So, naan na lang tayo 4 times negative 3 times 2 times 0.1. So, naata din hi ay negative 2.4. So, hinaot nga wakoy na sa yupan ni. 4 times 3 times 2 times 0.1. So we have here negative 2.4 and this 2.4 mo, i-replace na to din. So minus 2.4 all over 4 factorial. So that is 4 times 3 times 2 times 1 times 1 raised to 4. So our answer now is 0.3 minus 2.4 all over 4 factorials times 1 raised to 4. So we have here 0.2. So using formula for error, the relative error. So we have x raised to k plus 1 minus x raised to k is equal ni 0.2 minus 0.2. So of course the answer is 0. So as an observation di, using Taylor series expansion, maka-achieve ta og 0 na error if the highest order derivative in the problem kay mag-the same sa the order of kaning expansion. Parehas ni ba? Di ba ang given or ang problem is up to 4. Tapos, makakuha ta og accuracy ani nga perfect or error na 0 if i-derive po nato siya up to the fourth order. So pag abot og fifth order ani dili na pwede kay mas 0 naman ni siya tanan. So wala nay result pag abot at. So ingato lang, iato pa gamit sa ato ang Taylor series expansion. So any question po? So di lang na ako i-discard ang kuan ha, mga sulat-sulat para naamoy notes.
Excuse me, ma'am.
Yes po.
Ito gani sa H gani, ma'am. Sa first gani, ma'am. Sa
Sa-
first part, ma'am. Ba? Sa first part.
Ani,
Balik mo, ma'am. Sa...
narito akong photo
Balik mo, ma'am. Balik pa.
sa first part.
Ito ganing given gani, ma'am. Na-given dyan, ma'am. Kana gini xi plus 1 minus xi, ma'am, is equal to h. Ang
Oh,
kana yung xi plus 1, ma'am, himo siya 0 plus 1.
dili. Ang sa ang
Ang kana
xi
yung kanan
plus
mo.
1,
Yes, ma'am. Ang 1 is
ngano man,
automatic lagi, ma'am.
ngano man 0 plus 1, 1?
Nabibog lang ka, ma'am, ba? Kay, ano gan, ma'am? Katong,
Zero magud ang given na xi. Tapos nag-plus 1 man siya. So 1.
so, ang kanang xi plus 1, ang value na is 1, gini siya.
1 na siya kay, di ba gani ang ato ang, ay sorry. Saan ako? Kanito na.
Yes, ma'am.
Okay, right. Di ba mo na yung formula?
Yes, ma'am.
Tapos, given po ni.
Yes, ma'am.
Oh. So, kung kintahay, wala ta kabalo. So, pasabot, we have h plus xi. Kani mo pasabot? Given man ni siya. Tapos kani siya also is 0. So, ang ato ang ginapangita di ay is the value of that function at 1.
Ah, okay, ma'am. Thank you, ma'am. Sabot ako, ma'am.
Okay. So, any questions pa po?
Na ma'am.
Okay. So, anak lang ha. Mora gid may karon po dato ang topic. Saan man pagkuan? Nang po kabalo ani. Uy, altab. I-keep lang nako ang mga annotations para na amoy anay sulat-sulat daan kariya. So I'll be posting that one later. Ah. So before ko makalimot, mag-post ako og kuan ha o password. And I will leave you an activity
Okay, ma'am.
para ma-practice ta. Sa nila code ni 10389.
Tingog ng ice cream.
For your password, kindly check na lang po sa ato ang chat box. Basig makalimot ko ba? So, some more questions po.
None so far po, ma'am.
Yes, Alang.
Ma'am, excuse ma'am. Ma'am, katugod Friday, ma'am. Na murag na wonder ko ma'am ba kay wala ni Pops si attendance sa ako ma'am. Na question mark na siya kalit.
Mao ba? Wala ba ko unsay code nimo Alang?
72 po.
Check na ko ha. Basig wala po day ko ka-post.
Naman, ma'am, tong 2025.
Ana,
Sa
bitaw
Saturday lang,
Alang.
ma'am.
Look,
Saturday
Saturday lang.
kay wala gid sa Saturday na sayo pra ko og include Saturday pero dapat dili appeal si Saturday. Ay wala
Lagi-
gid ay 5 raman diri ah.
lagi ma'am kay pag ano na ko ma'am ba nga natingala gani ko nga wala lagi nagpapa pang attendance sa Friday.
Naman lagi sa imong mga classmate. Wala gid ka alam. Basta dili mo pop up, tan-awon nimo always sa ato ang attendance section.
Sige ma'am.
Kay na dito ang password.
Opo,
Dili na
salamat
siya,
po, ma'am.
dili na siya mo pop up. So always check the kuan, the Attendance section. Pareani ba? Kada lang ha. Ato siyang kuan. Pakita sa kintahay. Ani no? So, musulod ta daari. Tapos, look for the attendance section. So, natin So, mo ni siya ang ako ang kambyo-kambyuhan every time na dili ta mag-synchronous meeting. So, din ni siya mo gawas lang diretso. Always, tanawon pa nato din sa section na ni. Okay?
Yes, ma'am.
Okay, so later na lang siguro i-post na ko ang inyong first na activity. And deadline is of course before ta magklase na pud ugma kay ato na siyang i-discuss kung okay na ba ang all before ta mag-proceed na pud sa next na to na topic.
Ay, sige ma'am. Thank you ma'am.
Okay. So kung wala na po tayong concerns, kay pwede na po tayo mag-leave sa atong session and expect that natay activity. So that's all for today.
Today, ma'am, ang activity.
Thank you, ma'am.
Thank
Ang
you, ma'am.
activity is karon ako i-post pero ugma pa ang deadline. Pero nasa inyo ha og sugdan na ninyo or dili pa. Sige be, ako na lang dali raman ni. Dali lang. Ako lang isnip. So again, kay first exam coverage pamanta, all our activities and quizzes kay nara po sa unit 1. So this is our activity 1.1. 1 stands for unit 1 and that 1 stands for our first activity. Deadline is again tomorrow, 29, March 29. Time nato kay before 5:30. So 17:30 ang deadline. So naara ninyo ha, o sugdan na ninyo or dili pa. Karon kay marag fresh pa. Activity 1.1.
Okay na po, ma'am.
O kana ha, use 0 through second order lang takutob. Taylor series expansions to approximate the functions below. So that is the given value of x is 0, tapos atong pangitaon is the value of this function at 1. So we have here kaning duha lang. So kana lang. Wala man giingon to find the error, so okay lang that dili na ta mag-solve og error. So use lang the Taylor series expansion in identifying gikan sa 0 padulong sa second order. Okay? Nasabtan ra ba?
Yes, ma'am.
Yes ma'am.
Sige, so
So, pin-answer pa ba, ma'am?
pwede na dili, pwede na answer diretso. Basta all our answers must be handwritten.
Okay, ma'am. Thank you.
Okay, so that's all for today.
Thank you, ma'am.
Thank you so much for joining and tomorrow again. Bye-bye.
Thank you,
Thank you, ma'am.
Thank you, ma'am.
Thank you ma'am.
Thank you, ma'am. Love you.
Thank you, ma'am.